All right, friends, we asked for some help with problem 140 here. So chapter 3, problem 140. And what this is it's given us a function here. So y equals x cubed is our function. And we want to know at what point does, what value of the function does the a line tangent cross this point, which is the x-intercept, and they set that at 6, 0. So that's our constraint here. Obviously, we know we need to find the slope, so I'll say y prime equals 3x squared. We know we need that. For this, we're trying to find the x value, so we're gonna pick a letter to represent whatever that x value might be. And we're just going to go ahead and use that letter to pretend that we've found it. And we're going to plug it into a formula. You might want to use slope-intercept form here, but slope-intercept is for the y-intercept. So we wouldn't be able to use that. So instead, because we have this point right here, let's use our point-slope form, which we do not use very much. And it's y minus y1 equals m times x minus x1. Okay, my friends? So what we're going to do is we need to find, where is that slope, that point on the line? So I'm going to call our magic point that we're looking for, I'm going to call it C. That's our point that we're looking for on our x value for the curve. If that's my x value, what's my y value that goes with that on the curve? Wouldn't it be, look right here, wouldn't it be c cubed? Right? Whatever c is, I'm going to cube it, and that tells me the point on the curve. Yes? If I have this, can't I use that as my x1 and my x2? Oh, I need the slope. If I'm using c, can I use c in here too to say that m would be 3c squared? Whatever that point is. Well, I can plug all that in. So I'm going to have y minus c cubed equals 3c squared times x minus c. And from here, it looks like we want to distribute this over here. So I'm going to say that's going to be 3c squared x minus 3c cubed. I can combine these like terms here. So let me get that. Let me get this c cubed over to the other side. 3c squared x minus 2c cubed, because I'm adding a c cubed, right? And then now from here, we say, okay, what do we do from here? Well, it looks like I got this x and y, but this x and y has to be on this new line, which this is the equation of. But you already know what point you want on that line. It's right here at 6, 0. So I can plug that in here. So I'm going to plug in 0 for y, 3c squared times 6 minus 2c cubed. Well, this becomes 18c squared minus 2c cubed. Now I can just move that 2c cubed over here, divide everything by 2, and divide everything by c squared, and then I get c equals 9. So c is 9. That's the value that we're looking for on your point. So now we know what that x coordinate is. But I think it's, did it say it wanted the x coordinate, or did it say it wanted the line? I'm not sure. Let's pretend that we need to find the line, just in case. So if you need to find the line, I now have my actual point, so it would be 9, 729, using my point here. And then my slope at that point would be 243. Right here, plugging 9 in here. So there's my slope of the actual line, and there's the coordinate of the actual point on the curve. And then we would just use this sequence again. So y minus 729 equals 243 times x minus 9. Go ahead and distribute that 243. 243x minus 2187, I'm thinking. And then add that 729, 243x. Hang on a second. 1458. And there's my equation. So I can't remember if it asked for the equation of the line, that's it, or if it just wanted the value, what's the x value that works with that. And that's infamous problem 140.